Welcome to 5-3, division with monomials and polynomials. You can see in the first lecture notes, this is our first problem, which is a polynomial on top divided by a monomial. This is not long division. What it is a simple case of us reverting down to what we learned in 5-1. You can see that I took the monomial and placed it under each term of the polynomial on top, or the numerator. That allows me to work on them individually, and you can see that I have them grouped constants, p's on top of p's, t's on top of t's, r's on top of r's. That allows me to use the rules I learned in 5-1. All right, we can simply just use our calculator or mental math. 12 divided by 3 gives us 4. Now we got p to the third and p squared. This is the division problem. We learned in 5-1. One of the things we consider is which exponent is the smallest, which is the 2. So that means that the p to the third stays in the numerator. I'm going to go ahead and bring that 2 up, and we learn that it'll change to its opposite. We go to the next letter, it's t, and you notice we have a square on top, and to the first here, even though it's not written. And once again, we consider that the t squared stays in the numerator. We go ahead and bring the exponent up, and it changes to its opposite. And we got a nice little situation here. The r's are exactly the same exponent. That's the zero power rule for the exponent. So we can go ahead and cancel that out. You can see now that I'm going to simplify this, and I get 4p, do the subtraction to the first, and I got t, and that t will also be the first when you do 2 take away 1. All right, I'm going to go to the second term. Okay, I'm going to treat it as an individual because that's what it is. So 21 divided by 3 is 7. You can see here that the p's, which are lined up vertically, have the same exponent, so I'm allowed to just go ahead and cancel that out. We got a little special case here. Q has no letter in the denominator to simplify with, so it conveniently stays in the numerator. We have t to the first and t to the first, and what happens there once again is, since they're exactly the same, they cancel out, and now we're left with r. Notice that we have an r to the first in the denominator. Since this is the smallest, I'll bring it on up, so there'll be r squared and take away 1. Go ahead and simplify this, so 7 times q times r to the first, 2 take away 1. I'll bring down the subtraction sign. 9 divided by 3 is 3. We have our p's lined up. Once again, the 2 is the smaller exponent, so I'm going to bring it on up. Keeping the p3 in the numerator, I'm going to bring the exponent up, and it changes to its opposite. You can see here the t's have the same exponent. They're going to go ahead and cancel out. And we can do the same for the r since they're the same. I'll go ahead and simplify that. Negative 3 times p to the first. Our second problem, which is similar to the first, it's just written differently. You can see here I have a polynomial being multiplied by a monomial, but it has this -1. We've learned that, of course, that we can't have negative exponents, especially if they're outside the parentheses. What you should be thinking is that it could be written as a reciprocal. Okay, so 1's on top, and then the 4f squared. We can go ahead now, because this is a 1, remove the parentheses, and when we brought this -1 down, it changed to a positive. What that does is give you the idea is that this is actually now can be placed underneath, like the first problem. All right, and this is something new to the lesson, is this -1 outside the parentheses. We think we're going to reciprocate, so technically we just go ahead and take this monomial and place it under the denominator. And now we can go ahead and take the polynomial, place this monomial under each one, and like we learned in 5-1, each one of these is a separate problem. So we can have 4 divided by 4, cancels out. We get f in the numerator. Since this is smaller, I'm going to go bring it up, and that would be 5 take away 2. I'm going to go ahead and simplify that, and that would be f to the third. We have 6 divided by 4. We're going to leave it as an improper fraction, but we're going to reduce it, so that's 3 over 2. And that's going to be f in the numerator because the 2 is smaller. I'm going to bring that up, so that'll be 4 take away 2. I'm still going to get 3 over 2. And since the f is in the numerator, I'll just go ahead and multiply it by the 3. Simplify. 4 take away 2 is 2. Now, do not do anything. That is an individual answer. Keep it the way it is. I'll bring down the plus sign. Go to the next term. 12 divided by 4 is 3. My exponent in the numerator, or the denominator, is smaller, so I'll bring it on up. So f3 minus 2. I'll go ahead and simplify that. That'd be 3 times f to the first. Now I'll go to the final term. Go 8 divided by 4 is 2. Okay. And these two cancel out because the exponents are the same. All right. Most students have a tendency to place the 2 under each of the other terms here, but no, these are individual answers. We keep them exactly the way they are.